Hi, I just wanted to share a mental model that really helped me understand generics. There's a number of languages that use generics, and TypeScript's quite unique. But generally, this principle applies. So here we have some JavaScript, and JavaScript has many features and warts, as you probably know. But here I'm just going to go really basic. Here I've got a constant named favorite number, and that holds the value 7. So there's a number of primitive values in JavaScript like strings and numbers and booleans and so forth. Here it just holds 7. The next level are functions, and so constants, as opposed to functions, constants stay the same no matter where you run this thing, what time of day it is, whether you woke up in the morning feeling refreshed or tired. This thing will always be 7. But suppose that your favorite number did change depending on, say, whether it was rainy outside. And so we might say here that if it was rainy, my favorite number is 99, but if it's not rainy, it's 7. And so you can see here, depending on this value that's passed in here, this value that gets spat out the other side is going to change. And this dynamism is what allow our programs to be interactive and interesting and react to what input comes in. And so if we go back to a bit more of a realistic example here, I've got this double number function that accepts a n of that's some sort of number, and it times it by 2 to double it. And so you can see here that we pass in my favorite number, 7, of course, and 14 gets spat out the other side. So these two things actually look quite similar. So they're both const. They both have values that come out the other end. But this one thing has this additional preamble in the middle here, where it's got parameters and it's got this arrow. And so it's only by calling it that you sort of resolve out the final value at the other side. And so if I was doubling other numbers, I'm going to get different values out the other side. So types in TypeScript are very similar concept, really. So constants in JavaScript are values with names. Types have value specifications with names. And so a value specification effectively says what values are allowed or not allowed. So here I've got this type that's very restrictive, that only allows 7 to be my favorite number, but it could allow, say, all numbers. Or it could allow a small set of numbers. So it's a specification. So given a particular value, TypeScript can check whether that value fits into this particular type. But sometimes we want to go further. So often we just want a particular type, just like a particular constant will say the same no matter what time of day it is. A particular type will always look the same. A success error type might always just have the same shape. It might always, there's no reason for it to change. But sometimes we do want to have a bit of dynamism in our types as well. And so you do this by adding this generic parameter here. And so here I've got a thing I've called dual number. And so if we extend to see what this looks like, but by seeing the evolution, we can see how this works. So I'm going to call this favorite number 2, and I want to have it so that I spit out a little tuple, basically an array with just 2 items in it. And so you can see here I can create one for my favorite number to have that twice, but I'd like to go further. So just like how I was able to take my favorite number and extend it so that I could double more than just my favorite number, but double based on a parameter, I can do the same thing here. So I'm going to get past an n, and I'm going to replace all usages of that 7 with my n, just like I did up here. And you can constrain what these parameters are. So here I'm going to do maths, so I want a number. It might not be happy if n's sort of unknown. So I've said n has to be a number because I'm going to times it by 2. Here I've decided that I want n to be a number. So I'm saying it extends the set of types that hold all numbers. So n is going to be some sort of subset of that number. So n is effectively a number. So I can do that here. And that can, if I change my mind, of course that can change as well. So it's a very similar concept. So here I'm going to sort of call dual number, and I've passed in favorite number, so n here will be equal to the value specification that favorite number was, and it's going to spit out this shape. So you can actually see this by hovering over in TypeScript in VS Code. So favorite number is really just an alias for the type 7, and it's gone through here, run this expression at compile time, and then it's resulted in this type here. So if this changed, of course, this will change here as well. You actually saw there that it complained because this was string, but here it expects n to extend number, and number and strings never overlap. So here you can actually see it's a compile time error. So TypeScript is a blend of JavaScript and types. It's really 2 languages that execute at different times. So JavaScript executes at runtime, so it's going to run on some sort of server, like Node.js server. If something goes wrong, it's a runtime exception or some sort of bug or other subtlety. It's a bit subjective. But yeah, if something goes wrong, it might blow up on the server or blow up in the user space. TypeScript executes at compile time, so it's an earlier time than runtime. If something goes wrong, it's a compile time error or a compiler error. And so ideally that these two help each other. So ideally you try and catch things at compile time so that there might be fewer errors that occur at runtime. In TypeScript, when you write it out, every constant, variable, function, and class and other esoteric parts of JavaScript have a corresponding type. The 2 languages effectively sewn together. So you can see here what would just be JavaScript like so. That's valid JavaScript. Here we can have a bit more going on in TypeScript. And so I sort of think of this as the TypeScript part of the language. And then the rest of it is the JavaScript part of the language. And so in most compiled languages, they often spit out some sort of binary or executable that's machine code that will be, it's like an exe file or some other binary that will get run on a CPU. In TypeScript, the output is just JavaScript that executes. So effectively, the TypeScript compiler just goes in and just deletes all these types. And before doing so, it validates that all the types, that these 2 worlds agree. So generics help with this tapestry by allowing the types to flexibly adapt to the current scenario. So when you're, say, just have functions in JavaScript, your functions really help you adapt as different values are used. You can use and reuse the same function for different values and different problems, and it's based on those parameters that are passed into that function. And generics work in a very similar way, where you can have different types that are generated that adapt to the current scenario, and you can reuse these types for multiple problems, and it will help you solve problems where you sort of you can often break things into small functions that are easy to reason about and solve just 1% of the problem. You can do the same with your types and generics. So just like a function that doubles numbers doesn't need to know in advance every single number that could be possibly passed to that double number function, a generic type doesn't need to know in advance every single type that could possibly pass to itself. And the double number function, you can think of it like, of course, JavaScript can be a lot more complicated than this, but if you just think in terms of pure functions, it spits out a new value based on the number that was passed in as a parameter. So 8 was passed in as a value, it's going to double it, spits out 16. It spits out 16 as a value, and so in JavaScript we have these primitives where all the values are equal to another. So that one 16 is equal to another 16. There's no reference to a 16 where you can change it, or that now there's 18 different 16s. The dual number generic type spits out a new type based on the type that was passed in as a parameter, this n. So it actually spits out a new type. You can sort of generate new types, just how you can generate new values. And in the same way that values are equivalent to each other, the same value is effectively just the same thing. New types that look the same, that have the same structure, are all equivalent to one another. And so just in summary, these two have a lot of similarities. We've got these two things. One's called double number, one's called dual number. One's JavaScript, one's a JavaScript function. It gets passed in a parameter, n, which is a number, and runs some sort of expression on the right-hand side here. This type here gets passed in some sort of type that is a subset of number, and runs this expression on the right here. And you notice that these sort of two things look very similar. So they've both got this expression, they've both got parameters, they've both got names, and you can see that TypeScript's able to tell which word or which language you're writing by this prefix here. So just like functions allow our programs to vary and adapt when executing at runtime, generic types allow our programs to vary and adapt when executing at compile time.